So how does this recursion work in Java? I'm going to comment this out so you can see the method call of foo. Right, that's what we were executing. Right, oof, and there's our error. Lots and lots and lots of calls from basically foo calling foo, calling foo, calling foo, and saying an exception in thread main, stack lang overflow error. Okay, and this is referring to the runtime stack, which is a special stack that Java has to maintain method calls and the information about them. So the runtime stack keeps any new information it gets in an activation frame. This activation frame has the arguments that are passed into a method. It has the variables that we create in that method, if there are any, right? And it has the return address of the whatever called the method. Now these are called whether or not we've got a recursive method, right? This gets used whether or not we have. These get used for every single method call, not just recursive ones. But with recursion, it's good to see how this works, right? When you call a new method, we create a new activation frame and we put it onto the runtime stack, right? And what happens is that, like here, suppose we're walking through length ACE, right? So the bottom of the stack, this was called first. Length of ACE was called by someone else. We store that address there, and we also store the local variable ACE, right? The parameter that was passed in, rather. Then that's going to call length of CE, which will store CE in here, and it's going to have the return address of length ACE, right? The method that called it, which in turn is going to have the call length VE, which will have the return address for length, specifically the length that had, specifically it has the return address for the length that we were working in that had CE, and length of E is going to have the string empty string, so it's going to calculate length on empty string, and hold the return address of length of E. So once we are done with a method, we pop it off the stack, and we're in the we're back at the next level. We're back at the previous level. That will bring us back to whoever called us, right? So when this is done, this will pop, and when this is done, this will pop, and then when this is done, this will pop and go to whoever and pass back, and that will return control to whoever called length of ACE, right? The analogy for this is that suppose we have a office tower where every employee on that where we have an employee on each level that each has the same set of instructions. The employee on the bottom level, what he does is that he carries out a small, simple part of the instructions, and he calls up the employee on the next level, and the next level and the guy on the next level says, "Oh, yeah, give me a sec to work on that. I'm going to put you on hold." So the employee on the next level, he completes his small part of the task, and then he calls the employee on the next level, and that employee goes, "Oh, sure, I can do that. Here, wait a second. Let me put you on hold." The employee on the next level, he does his part of the task. He does his instruction, and he calls the next one, and so on until the top level is reached. Now, finally, the top level reach is like, well, why did this problem come all the way to me? This was an easy problem. He gives you the base case back to whoever called him, and the employee below him combines that answer with the work he did, passes it back to the guy who called him, and so on and so forth until we get all the way back to the bottom. So, so the runtime stack and the activation frames, they kind of just work together with the whole with this whole unwinding the recursion. That's what we were working through when we unwind the recursion.